Hello and welcome to Algebra 1 TAP Test 8. My name is Mr. Sipple and I'll be taking you through the study guide that will then allow you to retake the test. Really glad you're here. This was the first test of the new semester, so you want to start off the new semester on the right foot, and by being here that's definitely a good thing. Well, let's just go ahead and get started, and before we do, if at top right hand corner, if you'll just go ahead and write your name. And then for period, if you'll write your teacher's name, because some of you are coming from different teachers, so I want to make sure that we get this to the right teacher so we can help you raise your grade. And again, that's what this is all about. This isn't punishment. You didn't do anything wrong. We're just here to help you raise your grade. Alright, so just if this is your first time with us, just to kind of explain the format, you'll see that there's 3 columns that go across there. Problem 1.1, 1.2, 1.3, they're really all the same problems. The difference is the first column will be the column that I'll explain it to you, to kind of tell you how to do it. And then the middle and the right column will be for you to try. The one in the middle, I'll show you the answer first, because I want you to work the middle one out on your own. But then if you get stuck, you can continue to watch the video for an explanation to help you maybe get unstuck if you got stuck. And then the third column, I won't work that one out at all, because that's the one, by that point, we've taken the training wheels off the bike and you should be able to hopefully do it on your own. So I'll show you the answer for the third column, but I actually won't work that one out. Alright, and just in general, this idea of what does it mean to factor, throughout the video you'll notice in the right hand corner you'll see this little rewind button, and that's just my little visual cue to you to remind you what it is that we're doing here. The idea of factoring, and I've got it on the board here for you, rewinding or reversing multiplication. So what we're doing is we're just going backwards to say, what did something look like before it got multiplied? So for instance, this 5x plus 10 over here, there was some number on the outside that got distributed or multiplied to 2 numbers on the inside to give us 5x plus 10. So all we're trying to do is work backwards to say, or hit the rewind button, to say what was on the outside, what was on the inside that would give you 5x plus 10, right? Well, just as a little preview here, a little warm up, right? So if we said, well, what number must have been on the outside? Well, what we do is we look to see what the 2 terms have in common, or maybe another way to say that would be to say what number goes into each one of those. Well, it looks like each one goes in, 5 would go into each one of those. And then you ask yourself, well, 5 times what would make 5x? So if I was distributing a 5, what would need to be on the inside? Well, that would have to be an x. And then I would say 5 times what would make 10? Well, that would have to be plus 2. And I can, what's really nice about factoring is I can always check my answer to see if it's correct or not. Because if I distribute 5 times x, I get 5x. If I say 5 times 2, I get 10. So it's one of these things where you can always check your answer. Alright, so we'll go ahead and start off here with the first one. So you got 14z cubed plus 4z. So again, the first question we're asking ourselves is what number goes into both terms? Well, if I ask myself what goes into 14 and 4, well, that would be a 2. Right? So I know that what I could do is there must have been a 2 on the outside. And then I also ask myself, though, because maybe they don't just have a number in common, maybe they also share a common variable as well. So what you notice is they actually both have a z. So the 2z must have been what was on the outside of the parentheses. And then now what I'm just asking myself is, well, what would have been on the inside of the parentheses? Well, 2z times what would give me 14z cubed. And if you want to, you can even break this down into smaller pieces. Just ask yourself, first of all, 2 times what would make 14? Well, that would have to be a 7. And then you ask yourself, well, z times what would make z3? So almost think of it as we need 3 of them. We've got 1 right here, so that means that we would need 2 more. 2 times what makes 4? Well, 2. And we just need a z. We just need one z, and I've already got that one z, so I wouldn't need to add any more z's on the inside here. So what I'd get there would be 2z times 7z squared plus 2. And again, I can check, because see, if I multiplied, let me distribute. and you don't have to show this here, but I just want you to see what's happening is that if I distribute, I get 14z cubed, and then 2z times 2, I get 4z. So you see, I get the same thing that I started with, so that's that idea of reversing. So our answer there would be 2z times 7z squared plus 2. All right, so try number 1, try 1, 2. That's the problem in the middle there. And don't watch, pause the video now, try it on your own. And this is going to be true for all the problems that we do today throughout this video. Do as much of it as you can on your own. It's not going to help you if you just copy everything I write down. So you really want to be trying to do as much as you can on your own, and then only use in the video when you need to maybe get unstuck or to check your answer. All right, so go ahead and pause now and try 1, 2 in the middle. Okay, so hopefully you should have had a chance to try number 1, 2 in the middle. The answer there is 2y times 3y squared plus 7. Okay. So this would be a point if you got that one correct. Great. Go ahead and pause the video now. Try number 1, 3 on the right side. If you didn't get that as the answer, then maybe hold on and we'll explain to you real quick maybe what happened there. So again, we're asking ourselves what number goes into both terms. So what goes into 6 and 14? Well, that would be 2. And then we're asking ourselves, do they share a common variable? Is there a variable they both have? Yeah, they actually both have a y. So my greatest common factor would be 2y. And I'm just going to show you another way that this can also be written, or another way you might see this. Because kind of what we're doing is that we're dividing each one of those terms by the greatest common factor. And so this is a way if, on the first one I showed you is a little more mental. I was saying 2y times what makes 6y cubed, or 2 times what makes 6. Well, that would be 3. But another way that people like to look at this is say, well, 6 divided by 2, that would give me 3. y3 and a y would give me y2. And again, I could check that if I multiplied that. 14 divided by 2 would give me 7. And the y's cancel each other out, so that means that I don't need any more y's. And again, I can check my answer to see if this was right or not. If I distribute, I get 6y cubed plus 14y, which is, again, the exact thing that I started with. All right, so go ahead and pause now and try number 1, 3 on the right side. All right, so let's check to see what you got for number 1, 3 on the right side. You should have got 4z times 5z squared plus 4. If you didn't get that, then pause the video, try to figure out what went wrong there for you, and if not, I'm in the room here as well. So if any point throughout this video, if you need help, stop the video and raise your hand, because you're not just stuck with the video. You have support from me in the room as well. All right, so let's go ahead and move on to number 2. And so this one, you'll see the only difference is there's 3 terms, right? So instead of there just being 2 terms, there are 3 terms. But we're still asking ourselves the same question. What number goes into both terms? Do they share a common variable? So we're still asking ourselves the same questions there. So again, if I'm looking at, what number goes into all 3 of those, well, it looks like I can divide all 3 of those by 3. So let me divide each one of those by 3. So that would be, I know that there's a 3 out there for my greatest common factor. Now what I'm also asking myself though is, do they share a common variable? They do. They all have x's. And then what they actually have though is they don't just have one x in common, they actually would have 2. Right, because we look at the smallest power, the smallest exponent there. So at the very least, x3 has x2 with 1 more, and then x4, you could think of that as maybe having 2 x2s. So at the very least, though, they have 1 x squared in common. And then, so I would look at, well, what would be on the inside of that parentheses? Well, if I said 12 divided by 3, that gives me 4. x4 minus x2 gives me x squared. 9 divided by 3 gives me 3. 3 minus 2 gives me 1, or just x. I don't have to write the x to the first. 15 divided by 3 gives me 5. And then the x squared, you can think of those as canceling each other out. And then again, I can check my answer here. If I said 3x squared multiplied by everything on the inside there, 3 times 4 would give me 12. 2 and 2 would give me x4. 3 and 3 give me 9. 2 and 1, which would give me x3. And then 3 times 5, which gives me 15. And I got that x squared hanging out on the end, which again, compare. Look what I got right here. Same thing as we got right there. So that's this idea of hitting the rewind button. Again, we're just trying to go backwards to say, what did it look like before it got multiplied? All right, so go ahead and pause now and try 2, 2 in the middle. All right, well, let's check in with you, see how you did with 2, 2 in the middle. Should have 4y squared times 5y squared plus 2y plus 3. So if you got that, great. Go ahead and pause now. Try 2, 3 on the right side. If not, then we'll go ahead and walk through and see what happened here. So again, you're looking for the greatest common factor. You're looking for the biggest number that would go into all three of those numbers. And so 2 definitely goes into all three of them, but we're looking for the greatest common factor. We're looking for the biggest number that would go into all three. So that would be a 4. So my greatest common factor so far would be a 4. And then I'm looking at in terms of, you know, do they share a common variable? Yeah, they actually all have a y squared that they share. So I would also be dividing by y squared. Now on the inside, so I'd say 4y squared times what gives me 20y to the 4th. Well, 20 divided by 4 would be 5. y4 minus 2 would be y2. 4y squared times what gives me 8y cubed. Well, that would have to be 2y. And then 12 divided by 4, which gives me 3, and the y squareds cancel. And once again, I'm writing this, you know, you don't necessarily need to, when I'm checking my answer here, you don't necessarily need to write that. I think that's more really just kind of a quick mental check. Now, I'm writing it just so you see where I'm getting this from, but I think otherwise that would be something that you just do a quick mental check just to make sure that you have, that what you have here matches with what you started with. All right, so go ahead and pause now. Try 2, 3 on the right side. All right, well, let's check, see what you got over there. 2, 3 on the right side should have got 5z squared times 5z squared plus 2z plus 4. Again, if you got that, great. If you didn't, then pause, try to figure it out, or ask for some help. All right, so let's move on to the rest of the review, and the rest of the test focuses on factoring trinomials. Little tricycle down there on the bottom left corner. Tri just means 3. So what we're doing is we're saying, given a group of 3 terms, what got multiplied that would give you that. And we're going to actually look at 2 different types of trinomials. What we just saw, the problem before, it did have 3 terms, but we're going to be looking at a different type where what got multiplied was not just one number, but was actually two different groups, and we'll see that here in a second. All right, so again, the rest of the study guide is going to be the exact same type of problems that we're getting ready to do here. It's just that each problem, there might be one little thing here or there that's different, but otherwise, this is going to be entirely the same. What you see over here, the tool that we use to help us factor this is what we call the big X. You might have heard it called the diamond, the Xbox method. There's a couple different names for it. But the idea is that this is a tool that will help us factor this. And so what we're looking for with any of these problems, you know, what we've just started off with, is we're always looking to see, is there a number that goes into all 3 of them? So we always want to check for a greatest common factor first. And again, that's just looking to see, is there a number that goes into all 3 of them? In this case, I can divide everything by 2. I can divide everything by 2. So I've got 2 times, not 6, 3x squared minus 2x minus 8. Okay, so I'm always just checking for the greatest common factor first. Now, so what we're going to do to help us factor this is that we're going to be again, using this big X over here, and let me kind of show you how this whole thing works. First of all, you see that the big X, it says A times C and B. Well, where we're getting that, the A, B, and C from are these numbers right here. So, for instance, our 3 is our A, negative 2 is our B, and negative 8 is our C. So that's where we're getting the A, B, C from. By the way, you'll notice I'm not saying the A is not 6, B is not negative 4, and C is not negative 16. Because think of it as almost there's like there's an extra number in there. There's this extra 2, so we had to take that out first. So what we're really looking at as far as our A, B, and our C are these numbers right here, which is our A is 3, our B is negative 2, and our C is negative 8. So that's our A, B, and our C right there. Well, so let me go ahead and we're going to fill this out. And you'll notice there what it says is that when we fill in the big X, so A times C is what goes on the top. And, you know, just out of habit, just to remind yourself that's where it comes from, I think it's a good idea. You know, you could go ahead and just write in A times C. And then B is the number that goes on the bottom there. So A times C would be 3 times negative 8, which would be negative 24. And then our B is negative 2. And the way this thing works is that you're looking for two numbers that multiply to the top. And we want those same two numbers to also add up to the bottom. So if you think about the different ways that you can multiply to 24, and you know, numbers might jump out in your head. You might say 8 and 3, but then you're like, wait, that doesn't add or subtract to 2, so I don't think that'll work. 12 and 2, no, that won't work. How about 6 and 4? And you'll notice that this number is negative, so what that means is that one of these numbers has to be negative. And this is always the tricky part of trying to figure out, okay, which one do I make negative? Well, look at the bottom number. The bottom number tells you there's more negatives left over. So if there's more negatives left over, there must have been more negatives to begin with. So one thing to remember on these is that when the signs are different, you look at the bottom, if the sign of the bigger number and the sign of the bottom will match. Right, so those numbers match. And then now what I'm going to do is I'm going to take those numbers and I'm going to print those in parentheses. I still have that 2 out front as my greatest common factor. And then I'm going to take the other two numbers that I got from the big X. So I'd have x minus 6 and x plus 4. And then this is going to be a real crucial part of how the big X works, is that you have to divide by A, whatever your A is, and it changes from each problem. In this case, our A is equal to 3, as we've already said. Right? Our A is equal to 3. So it's going to be different for each problem, but you have to divide both by A. Now, the last part that we have with this is that little catchy little thing that we'll say quite a few times. If you can't divide it, slide it. What we're looking for is that we're saying if you can divide those numbers, then go ahead and do that. But if you can't divide them, then the numbers just stay as they are. So x minus 6 divided by 3, well, that would give you x minus 2. And then again, if you can't divide it, slide it. So you can't divide that evenly, so we're going to go ahead and slide that. So that's going to become 3x plus 4. And that becomes my final answer there. Again, the order doesn't matter, by the way. If you put 3x plus 4 and x minus 2, that would be the exact same thing. So if you recall that multiplication is commutative, meaning that the order does not matter. All right, well, so go ahead and pause now. Try 3, 2 in the middle. All right, should have had an opportunity at this point to do number 3 in the middle there. So should have got, it had a greatest common factor of 2, and then the factors would be 3x plus 1 and then x plus 5. If you got that, great. Give yourself a pat on the back. Pause it, try 3, 3 on the right side. But if you didn't get it, then let me see if I can help you get unstuck here. So again, we're always checking for a greatest common factor first. Right? Always checking. And I say check because maybe there's a greatest common factor there, maybe there's not. In this case, there is. Right? So we can divide everything by 2. So we do have a greatest common factor here. I'm going to divide by 2. And so when I do that, right, so I take my greatest common factor out. Again, think of it as almost kind of this extra number that's in there. So I've got 3x squared plus 16x plus 5. All right, so now I'm ready to use my big X on this one. So I'm just going to go ahead and fill in my big X. And so it's going to go a times c. Go ahead and draw that. Again, always a times c on the top, b on the bottom. So again, looking at your a, b, and c, right? There's our a, there's our b, and there's our c. And it's always, by the way, there's never x's or x squareds that go into the big X here. It's only numbers. It's just the coefficients, right? The numbers in front of the variable that would go. All right, so 3 times 5, which would give me 15, and then my b, which is 16. And again, looking for two numbers that would multiply to the top, those same two numbers also add up to the bottom. Well, if you think about what multiplies to 15, you think 3 and 5. Oh, wait, but that doesn't add up to 16. Oh, how about 15 and 1? Yep, that'll multiply to 15 and add up to 16. All right, so let's come over here with it. We're going to take our factors. And again, we have this greatest common factor of 2. And then our factors, x plus 15 and x plus 1. But we really can't call them our factors yet because we need to divide by a. So we will always, always, always be dividing by a. And in this case, our a is equal to 3. So I'm going to be dividing by 3. And once again, if you can't divide it, slide it. So we're looking to see, is there a number that we can divide by? And in this case, yes, there is. 15 divided by 3 would be 5. And now 1 divided by 3, that doesn't divide evenly. So if it doesn't divide evenly, that's where I'm going to slide it. So that would become 3x plus 1. And again, I can check to see if that was correct by multiplying that out. All right, so pause now. Try 3, 3 on the right side. All right, well, let's check in with you, see what you got. For 3, 3 on the right side, should have got 2 times x minus 5, 3x plus 1. And again, the order doesn't matter. So if you'd written 3x plus 1, then x minus 5, that's fine, right? So again, order does not matter on these. All right, well, moving along here, let's take a look at number 4. And again, by the way, from this point out through the rest of the video, every single one of these problems is pretty much exactly the same setup. There's just each problem there might be 1 or 2 little things here or there that are different, but the idea of the big X is going to be the same for all of these. So for instance, for all of these, we're going to check for a greatest common factor. Now if I look at this, I say, well, is there a number that goes into 2, 3, and 1? Well, there's not. So on this one, there is not a greatest common factor. So that's why we say check. Maybe it's there, maybe it's not. All right, now as far as labeling our A, B, and our C, right, so we do want to do that. And this, you know, again, I line this up for you so you could see, you know, where we're coming from on this is that this is your, right, there's your A, there's your B, and there's your C, right? So it's just the numbers lined up from left to right in that order, A, B, and C. All right, well, let's fill in our big X. So let's see what we would have there. And A times C on the top, as always. B on the bottom, as always. All right, A times C would be 2 times 1. Okay, well, that's 2. Easy enough. Number on the bottom, our B, would be 3. We're looking for 2 numbers that multiply to 2 that would also add up to 3. Sometimes we forget about 1 and the number we're looking for. Now, for instance, 2, the only way you can multiply to 2 would be 2 and 1, which also adds up to 3. All right. Now, so we're going to come back over here. So we've got A plus 1 and A plus 2. By the way, the only thing that's different about this problem as compared to the last problem is that there was no greatest common factor on this one, whereas in the last one there was. So you'll notice that from here on out through the rest of this particular problem, everything's going to be the same. All right, divide by A. And again, we see our A is Okay, there's our a. A is equal to 2. So I'm going to divide both sides by 2. And then again, if you can't divide it, slide it. So I need to see if I can divide it or not. Well, 1 and 2 does not divide evenly, so I will be sliding that. So that ends up being 2a plus 1. Now 2 divided by 2, that does divide evenly. 2 divided by 2 is 1. And then there we are. Alright, so pause now. Try 4-2 in the middle. Alright, let's check in with you. 4-2 in the middle should have come up with 2a plus 1 times a plus 3. If you got that, go ahead and pause. Try 4-3 on the right side. If you didn't, then let me start setting it up for you. And then the moment that you catch your mistake, I want you to pause the video and see if you can finish it on your own, right? So again, if you're just copying down what I'm writing, it's not going to really do you that much good. You really want to be trying to do as much of this as possible on your own. All right, checking for greatest common factor. That will always be the first thing that we're going to do. Is there a number that goes into 2, 3, and 1? Well, no, there's not. So that won't work. Alright, by the way, I just caught the typo here. I'm sure you probably were already yelling at the screen and saying that you caught it. Yeah, you know, I thought this was a updated version of what I had. Well, so what there was, you notice that 4-2, 4-1 were actually the same problems, or at least what I had on here. Should be 2a squared plus 7a plus 3. Which I'm pretty sure is what it should be on the copy that you have. So let's try that all again. Apologize for the epic fail here. I record these all in one shot, so unfortunately I don't have a way to go back, so we just got to deal with it as it goes. Alright, so 2a squared plus 7a plus 3, so what you should have had there, 2a plus 1 times a plus 3. How about that? That's the right problem with the right answer. If you got it, great. Go ahead and try number 4-3 on the right side, which is correct. But if you didn't, then let me walk you through what this one should have been. So again, checking for a greatest common factor, because we're always doing that. And I notice there's not a number that goes into 2, 7, and 3. So that's where I then go into say, all right, well, I'm going to fill in my big X. And I'm always just making sure that I correctly identify what's my A, my B, and my C. So for instance, if I look at this one, I see that, okay, my A is equal to 2, my B is equal to 7, and my C is equal to 3, right? So there's my A, B, and my C. So I'm going to go ahead and fill in the big X. And what I'm going to be looking for, it looks like, is two numbers that multiply to 6, right? Where we get 6 from? Well, because A times C, so 2 times 3, which would be 6. And adds up to 7, which is our B. Well, so 2 and 3, that multiplies to 6, but that won't make 7. Oh, okay, how about 6 and 1? Right, 6 and 1 works. And let's go ahead and put those in our parentheses. So we've got A. I almost started writing X. Let's fix that. So we've got A plus 6 times A plus 1. Once again, as always, we're going to divide by A. And when we divide by A, if we can't divide it, then we're going to slide it. So let's see what happens here. Our A, in this case, is 2. So we're going to divide by 2. And 6 divided by 2, I can do that. That divides evenly, which would be 3. And then 2, 1 and 2 do not divide evenly. So I'd end up with 2a plus 1. And again, order doesn't matter. You notice that I ended up, my answer is a little backwards from what I had just written above it. But again, that's just to show you that the order doesn't matter. Alright, so go ahead and pause now and try number 4-3 on the right side. Alright, let's see what you got for 4-3. Should have got 2a plus 1 and a minus 5. Alright, so let's move along to number 5. That's the last one on the front side here. Alright, so, you know, when you look at it at first, you're like, I don't know, looks pretty much the same thing. Well, yeah, and in a lot of cases, it does look the same. So we're just going to go through the same process, same procedure here. You know, we're going to check for a greatest common factor. Is there a number that goes into 6, 5, and 6? There's not. So then that's when I'm going to go and fill in my big X. As far as my A, B, and my C, right, I can see that my A is 6, my B is 5, my C is -6, right? So there's my A, there's my B, there's my C, right? And you might notice, by the way, that, you know, in the other problem I'd highlighted the ABC, and this one, you know, I wrote ABC and drew some boxes around it. So I just want you to see that there's, you know, a couple different ways that you can label these things. There's not just one right way to do it. You know, sometimes I just mix it up just for fun, or as much fun as this can be. All right, A times C, so 6 times -6, which would be -36. And your B, which would be a +5. And looking for two numbers that multiply to -36, and we want those same two numbers to also add up to a +5. You know, 6 and 6 is kind of the first thing that jumped out in my mind, but then I know 6 and 6 will not add or subtract to 5. Oh, how about 9 and 4? And then I've got to decide, okay, well, is there, which one of these is going to be positive, which one is going to be negative, right? Because to multiply to a -36, the signs would have to be one positive, one negative. Well, so there's, if I look at the B, it's positive, so that means there's more positives left over. So if there's more positives left over, that means there's more positives to begin with. So the bigger number would be positive, and the smaller one negative. And even if you're not sure, just check. 9 minus 4 is 5. Okay, well, that worked out. All right, no GCF on this one that we had to worry about, so now we're just going to come over here. So we've got C plus, not 6, C plus 9, and C minus 4. And then we're going to divide by A, right? So same story. Divide by A, and again in this case, our A, right? There's our A right there. It's 6. Now, you might already notice what's a little different about this one, and what's going to happen in this next step is the only thing that's different about this problem as compared to the previous two. You notice when we go to try to do our, if you can't divide it, slide it, what you notice is that actually neither one of these divide evenly, right? Well, so what does that mean? Well, you know, part of, if you can't divide it, slide it, part of dividing means, well, can you reduce it? You know, is this a fraction that you can at least reduce? You can reduce this fraction. So what I can do is I can divide this one by 3, and I can divide this by 3 as well. This one, 4 and 6, I can divide that by 2. So these numbers might be different. What you reduce by, that might be different. So I don't think that's always going to be the same thing. So when I reduce, then I've got C. 9 divided by 3 would be 3. 6 divided by 3 would be 2. And then 4 divided by 2 would be 2. 6 divided by 2 would be 3. Right. So now if you can't divide it, slide it, right? Well, so it looks like I can't divide these evenly. I can't reduce them any further. So then if you've taken it as far as you can take it, which we have in this case, then you're going to slide it. But don't be tempted to slide 6 here, because you had to reduce it first. So again, part of if you can't divide it, slide it, you also are checking to see, well, can I reduce it? So this would end up being 2c plus 3 times 3c minus 2. All right, let's try number 5 in the middle. So go ahead and pause now. Try number 5, 2 in the middle. All right, so let's check in with you. So, ooh, too fast. So 5, 2 should have had 5c plus 4 and then 2c minus 1. So same drill. If you got it right, awesome. Go ahead and pause now. Try number 5, 3 on the right side. If you didn't, let me try to get it set up for you here, and then again, once you catch your mistake, if you catch the mistake, pause and try to finish the rest of the video on your own. All right, checking for a GCF. Checking for a GCF. Nothing that goes into 10, 3, and -4, right? And by the way, you know, again, you might get a little tired of hearing me say check for a GCF, fill in the big X, divide by a. If you can't divide it, slide it, right? But part of this is through a little bit of repetition. We're just trying to get it to stick in our brain. So hopefully by making a habit out of that, then we've learned it. All right, so I've checked for GCF. I'm good there. I just need to fill in the big X. So let me see what I've got. A times C, B on the bottom. And let me go ahead and label my A, B, and C. There's my A, there's my B, there's my C. All right, A times C, well, that's 10 times negative 4. That'd be a negative 40. Make sure you get the sign correct there. And a positive 3. So if I think about what multiplies to 40, well, there's 4 and 10. Oh, but wait, that won't add up to 3. Oh, 8 and 5, right? So, and then I'm left again with this question of which one do I make negative, right? Because I notice this is a negative 40, so I know that one of these would need to be negative. Well, again, there's more positives left over on the bottom, so that means the bigger number would need to be positive, which means the smaller number in this case would be negative. All right, so let's take those two numbers. So we've got C plus 8, and then we've got C minus 5. And we need to divide by A, as we do every time. Let's make sure we identified our A. Right, there's our A right there. Our A is 10, so I'm going to divide by 10. And if I can't divide it, slide it. But as we've seen in this particular problem, before you divide it, right, before you slide it, you need to see if you can reduce it, right? Because you notice that neither one of these numbers divide evenly. However, you can reduce them. So what goes into 8 and 10? Well, that would be 2. And by the way, I'm writing the little divided by 2. You could write that, or that, that's something that could be done mentally as well. So that's not something that you'd have to write down. All right, so 8 divided by 2, which would be 4. But I'd encourage you to do it. I think that's a good way to keep track of, what exactly it is that you're doing. 10 divided by 2, which would be 5. So I'm just keeping it as a fraction. 5 divided by 5 would be 1. 10 divided by 5 would be 2. All right, so now I've reduced it. Can't divide it, so I'm going to slide it. So let's go ahead and slide. Slide that 5 on over. Slide that 2 on over. And let's see what we get. So should end up here with a 5c plus 4 times 2c minus 1. And there you are. All right, so pause now. Try 5-3 on the right side. All right, so let's check in with you. 5-3 on the right side should have got 3c minus 4 times the quantity 2c plus 1. So that's what you should have got for number 5-3 on the right side. All right, well, let's go ahead and hey, we're halfway home. Turn over to the back side, and let's take a look at number 6. So hang in there. We're halfway there. All right, again, you look at it, you're like, wow, it looks exactly like every other problem has looked. And initially, it will look all the same. As I said, there's just, on these, there's maybe like one little thing here or there that makes it different, but otherwise, the setup is going to be the same. So we're still checking for a GCF, and we hadn't had a GCF in a while, but I think we got one this time, right? What goes into 210 and negative 28? That would be a 2. So we do have a GCF here. So that's why we say check. Maybe it's there, maybe it's not. But you have to be in the habit of checking for it. All right, so 2 divided by 2 is 1, or maybe I just write m squared plus 5m minus 14. All right, so let's go ahead and identify our a, b, and our c. Oh, wait, what's my a, right? So this is what's different about this one, because you're like, okay, there's b, there's c, what happened to a? Well, you look at what's really in front. It's that guy that never gets any love, 1. So your a is actually equal to 1. So if you notice, every single one of these problems previous to this had an a greater than 1, maybe 2, 3, 5, 10, something like that. But in this case, the a is actually equal to 1. Well, I hadn't told you this yet, but we actually started with the most difficult problems, and we're kind of working downhill now. When a is equal to 1, and you'll see in a second, it actually makes the problem a little bit easier for us. So let's see what maybe I'm referring to there. All right, we're going to fill in the big X. That part's the same. And I've got a times c. I got my b on the bottom. So a times c would be 1 times negative 14, which would be a negative 14. Your b, which would be a positive 5. Looking for two numbers that multiply to a negative 14, and we want those same two numbers to then also add up to a positive 5. Think about what multiplies to 14. I'm thinking 7 and 2. And I've got more positives, so that means the bigger number would be positive, meaning the smaller number would be negative. Smaller number would be negative there. All right, so let's take, and I've got the GCF of 2, so I want to make sure that I write that. And then I'm taking my numbers here, and I've got x plus 7, and then I've got x minus 2. And then I need to divide by a. So let me see, if I divide by a, which, and again, in this case, my a was equal to 1. Here's why this is easier. All right, well, let's do our old if you can't divide it, slide it thing. And then you're like, wait, 7 divided by 1 is 7. Okay. Negative 2 divided by 1 is just negative 2. Okay, well, what'd you notice? Well, it stayed exactly the same, right? Nothing, when we went to go do our divide it, slide it, nothing changed because we were dividing by 1, right? If we were dividing by something else, then it would have changed. But in this case, it didn't. So when a is equal to 1, that's what makes it a little bit easier. When you go to divide by a, you end up with the same thing. So there's no reducing it. You don't have to slide anything. So in that way, that makes it a little easier. All right, so go ahead and pause now. Try 6-2 in the middle. All right, so let's see what you got for 6-2 in the middle. So should have got 2 times m plus 5 m minus 3. If you got that, great. Pause. Try 6-3 on the right side. If not, let's take a look at what happened here. Checking for a GCF. And if I look at it, it looks like I can divide everything by 2. So let me divide everything by 2. So I divide by 2. And so my greatest common factor, let's throw the 2 out front. And again, the idea of the greatest common factor, just think of it as almost kind of as like this extra number that's in the problem. So we got to be able to get down to our true a, b, and c, we got to get rid of just the extra numbers first, and then we can get in there. So if I look at my a, b, and my c, there's my b, there's my c. Again, the thing that's different about this one is that your a is equal to 1. Only thing that's different there. So we're still going to fill in the big X. So what I'd be looking for is two numbers that multiply to negative 15, right, because we're doing a times c. And those same two numbers we want to then to also add up to positive 2, which is our b. Well, so I'm thinking 5 and 3. And again, I got to figure out which one to make negative. Well, the bigger number will always match the sign of the bottom here. So since the bottom number is positive, that means the bigger number would be positive, which in this case means the smaller number would be negative. All right, so let's take our greatest common factor, which is 2, and then let's take our factors from our big X, x plus 5 and x minus 3. And I want to divide by a, and as we've said, when a is equal to 1, it makes it a little bit easier for us because we don't have to worry about reducing or sliding or any of that stuff, really. Divide by 1, and so we end up with x plus 5 times x minus 3. Oh, I just caught myself. Actually, not x, right? I get in a habit of doing that. So I just looked up no x's. We're talking about m's. Right, same thing, but obviously we want to be correct with our variable. All right, so pause. Try 6-3 on the right side. All right, so let's see what you should have got there. Should have got 3 times m plus 5 times m minus 2. All right, so let's move along. Let's take a look at number 7. So you see that the a is not equal to 1 here, so we're going to have to do some dividing and sliding again, but that's all right. So hopefully at this point we've gotten enough practice at it that we feel pretty good about that. Checking for a GCF as always, and nothing that goes into 4, 12, and 9, right? Okay, so don't have to worry about GCF. As far as our A, B, and our C, let me go ahead and label that. There's my A, there's my B, and there's my C. I do like labeling the A, B, and C just so that when I'm filling in the big X, I can look up at it and I've already got it labeled. When I go to divide by A, same thing. I can see what my A is equal to. So I got A times C and B, which would be 4 times 6, which would be 36. And then I got a negative 12 on the bottom. Think about what multiplies to 36. Well, 9 and 4, but that won't add up to 12. Oh, 6 and 6. And now 6 times 6 multiplies to a positive 36, but doesn't add up to a negative 12. So I would need to make both of these negative so that it would add up to a negative 12. Now, this one point right here, this is the only thing that makes this different. You'll notice that these numbers are the same on both sides of the big X, negative 6, negative 6. So that is a particular type of problem that we refer to as a difference of squares, and you'll see maybe in a second why we refer to it as a difference of squares. But yeah, so the numbers are the same, but it doesn't really change how we go about filling in the big X. We're still going to divide by A. So all of that stuff is really still the same. So we've got n minus 6. And then when we're done, at the end of this one, I'll show you what we can, a shortcut maybe that we can think of here. All right, so we're going to divide by A, which in this case is 4. So let's divide both sides by 4. I'm going to divide by A. And what I notice is that, well, it doesn't divide evenly. So remember, when it doesn't divide evenly, when neither one of them will divide evenly, that's when we have to reduce first, right? So that's part of, if you can't divide it, slide it, is you have to reduce. So we need to reduce, and I'm thinking that we can divide both of these by 2. And since they're the same number, we're going to be dividing by the same number. So in 6 divided by 2 would give me 3. 4 divided by 2 would give me 2. Again, 6 divided by 2, well, I kind of already know what it's going to be, right? Since it's the same thing, which would be 3 over 2. So now, if you can't divide it, we're going to slide it. Well, I can't divide it any further. I've already reduced it all that I can. So I'm going to slide over the 2 and slide over the 2. And then so what we end up with there would be 2n minus 3 times 2n minus 3. Now, because they're the same thing, because it's 2n minus 3 2 times, right? There's 2 groups of 2n minus 3. What we can do, and it wouldn't be wrong if you left your answer this way, but what we can do to simplify it further is that we don't have to write it twice. We can just write it once to the second power. So I could write 2n minus 3 squared. Okay. Now, again, I mentioned earlier about this being something called a difference of squares. And actually, this particular one, I misspoke. Not a difference of square, a perfect square trinomial, I meant, sorry. 9 o'clock on a Sunday night. But what you'll notice is that these numbers are perfect squares, meaning numbers that you can take the square root of. So you'll notice the square root of 4 is 2, square root of 9 is 3. So perfect square trinomial, which this one is, and then in a second I mentioned the difference of squares. We'll look at the difference of squares one in a moment. All right, so go ahead and try 7, 2 in the middle. Okay, so let's see what you got with 7, 2. And I do want to be clear, by the way, that I misspoke a moment ago in saying that this was a difference of squares. We'll actually look in a second at a difference of squares. This is a perfect square trinomial. Because a trinomial, because there's 3 terms, 1, 2, 3, but also perfect square because you can take the square root of the first and the last number. So didn't want to confuse you on that. All right, so 2n plus 5 squared. If you got that, great. If you didn't, pause. Go ahead and try number 3 on the right side. Otherwise, we'll go ahead and see what happened on this one. So checking for a GCF. Same thing here as always. No number that goes into 4, 20, and 25, however. So I can go straight to labeling my A, B, and my C. So A, B, and C. B, and C. And let's go ahead and fill in our big X. So I'm looking for 2 numbers that multiply to 4 times 25, which would be 100. And then also add up to b, right, which in this case is 20. So what multiplies to 100 that adds up to 20? Well, that would be 10 and 10. And both positive, right, because we're adding up to a positive 20. So let's put those in parentheses. So I would have n plus 10 times n plus 10. And then we're going to divide by a. So let's see, divide by a, which in this case our a is equal to 4. So let's divide by 4. And then I can't quite divide it. Can't divide it evenly. So what I am going to do, though, is I'm going to reduce. So let's divide top and bottom by, in this case, 2. And again, because they're the same numbers, we're going to be dividing by the same amount. 10 divided by 2, well, that would give you 5. So n plus 5 over 2. And n plus 5 over 2. So can't divide it evenly, can't reduce it any further. So if you can't divide it, slide it. So we're going to go ahead and slide that on over. So slide that 2 over. Slide that 2 over. So 2n plus 5 times 2n plus 5. And as we said, this being a perfect square trinomial, all that means is that if you see the same thing twice, you don't have to write it twice. You can write it once to the second power. And to the second power, because there's 2 of them, right? There's 2 groups of 2n plus 5. All right, so go ahead and pause. Try 7-3 on the right side. All right, so let's see what you got. 7-3 on the right side should have got 2n plus 1 squared. All right, so moving along, just to have a couple problems left here. So let's go ahead and take a look at number 8. So we've got r squared minus 10r plus 25. So this one might even look a little easier to you because it seems like there's a little less going on. Checking for a GCF. Well, nothing that goes into all 3 of them. Let me label my A, B, and my C. A, B, and C. Again, you'll notice that the A, since there's no number in front, well, there is really a number in front. It's just a 1. So let's make sure we write that in. So that's a 1. That's a negative 10. And that's a positive 25. So let me go ahead and fill in my big X here. So A times C, which would be 1 times 25, which is 25. And then my B, which is negative 10. Looking for 2 numbers that multiply to 25 that would add up to negative 10. I'm thinking 5 and 5 multiplies to 25. But 5 and 5, at least positive, right, adds up to a positive 10. I need these 2 guys to add up to a negative 10. So they would need to both be negative. No GCF to worry about. I've got r minus 5 times r minus 5. And divide by a. And I know that the a is equal to 1, and I know it's going to end up being the same thing. But I just want you to be in the habit of dividing by a, even when it's equal to 1. And you know it's going to be the same thing. But the problem is that once you stop dividing by a, you won't do it on the rest of them, right? So this is the only problem where when a is equal to 1 where you can kind of skip that part of it. But I want you to be in the habit of writing divided by a. All right, and as we said, if you see it twice, you don't have to write it twice. You can just write it once. So you'd have r minus 5 squared. All right, so go ahead and pause now. Try 8-2 in the middle. All right, so let's check to see what you got with 8-2 in the middle. Should have r minus 4 squared. If you got that, then bravo. You can pause and try number 8-3 on the right side. If not, again, let's see maybe if we can figure out where things went wrong for you. All right, check for a greatest common factor. There is none, right, because there's no number that goes into all 3 of those. Let's identify our A, B, and our C. So our A, B, and C, my A is equal to 1, and my B would be equal to negative 8, and C would be equal to 16. All right, let's go ahead and fill in the big X. So A times C and B. So 2 numbers that multiply to 16 that add up to a negative 8. I'm thinking 16, I'm thinking 4 and 4. And to get 4 and 4 to add up to a negative 8, they would both need to be negative. And, you know, if I multiplied negative 4 times negative 4, that gives me a positive 16. So that works too. All right, so no greatest common factor I got to worry about. So let me just throw down here r minus 4, r minus 4. I want to be in that habit of always, always, always dividing by a. And in this case, as we know, our a is equal to 1. So we know that it's going to stay exactly the same. So I've got r minus 4 times r minus 4. Again, don't have to write it twice. Write it once to the second power. So r minus 4 squared. All right, so go ahead and try 8-3 on the right side. And let's see, hopefully at this point you had a chance to try 8-3. So should have got r minus 7 squared. R minus 7 squared. All right, 2 more to go. We're almost there. Oh, wait, hey, this looks a little different, right? So you notice what happened here. Hey, there's only 2 terms, right? So that looks a little different. Well, let's see what's happening here with this one. You know, again, we always want to check for a greatest common factor. So if I divide, I see that there's both of these actually I could divide by 2. So greatest common factor on the outside, which would be 2. And then what would I have left would be 4t squared minus 25. And now, so this one looks different, right? So this one and 9 and 10 are the same type of problem. It's a difference of squares. And we'll see what's happening here. As you see, there's only 2 terms. And so we've been talking this whole time about a, b, and c. Well, so what's happened here is that if you notice, there's something missing. Well, the a is always the first number that's in front of the squared term. So that would be my a. The c is always the number that's last, that's by itself. So what you'll notice here is that there's actually no b. The b is missing. Well, if the b is missing, right, because let me make him disappear, right, because that's what it really kind of looks like, just a and c. Well, if the b is missing, then that means that it's equal to 0. So when I go to fill in my big X, when I do my a times c, and I got my b on the bottom, so my a times c would be 4 times negative 25, which would be a negative 100. And then my b on the bottom would be 0. So I'm looking for 2 numbers that multiply to a negative 100 that add up to 0. Don't put 50 and negative 50, right? That doesn't, that adds up to 0, but it doesn't multiply to 100, right? What multiplies to 100 would be 10. And then to get that to add up to 0 would be a negative 10. Reason why we call this a difference of square, a couple of reasons here. First of all, if you look at, what's the square root of 100? It's 10. Difference, meaning that there's one as a plus and one as a minus. So let me go ahead and put this in our parentheses. So I've got 2 times t plus 10 times t minus 10. And then that's going to be divided by a. And our a in this case, right, that's our a right there, is 4. So still dividing by a, that doesn't change anything. And by the way, the big X is exactly the same from here, so there's not going to be anything that's different. You'll notice that we have to reduce, because I can't divide either one of those evenly, so I'm going to have to reduce. So let's reduce both of those, and I can reduce both of those by 2. And so when we do that, end up with t plus 5 over 2, t minus 5 over 2. Now this is our last part of it, where now that we've reduced, what's happening here? Lost a c. Now that we've reduced, now we can slide it. So let's go ahead and slide it on over. So slide the 2, slide the 2. So 2 times 2t plus 5 times 2t minus 5. Now don't write squared, right? Because they're not identical. A 2t plus 5 is not the same thing as a 2t minus 5. And going back to, I mentioned this idea of something difference of squares. So if you look at the square root of 4, it's 2. Square root of 25 is 5. Difference because one is a plus and one is a minus. And the problem will always start off as a minus. But like I said, even if you don't pick up on that pattern, just crank it out with the big X, you'll get the same thing. All right, so go ahead and pause and try 9-2 in the middle. All right, so let's see what you got with 9-2. So for 9-2 in the middle, you should have got 3 times 3t plus 2 times 3t minus 2. If you got that, excellent. Pause, try 9-3. If not, then let's take a look at what happened here. So as we've said all along, checking for a greatest common factor, so nothing new there. If I take a look at it, it looks like I can divide both sides, or both terms, by 3. So I ought to have a 3. And then what would be left over there would be 9t squared, right? Because 27 divided by 3 would be 9. 12 divided by 3, which would be 4. And again, so this is what's different about this one, is that the ABC, the B is missing, right? So again, if I pulled this over here and I lined up my AB and my C, let me shrink this down just a little bit there. So what I notice is that there's only 2 numbers, right, instead of 3. Well, here's the squared term, so that's my A. The number that's back there by itself, that's the C. So again, what's happening here is that the B happens to be equal to 0. And so since it's equal to 0, it doesn't get written. So really, all that you're working with there would be A and C, or at least all that's visible. So let me go ahead and fill in my big X. So I've got A times C and then B. So 9 times negative 4, which would be a negative 36, and 0 on the bottom. So I'm looking for 2 numbers that multiply to negative 36 that add up to 0. Well, that would be positive 6 and negative 6. And one of the things with these difference of squares is that the numbers on the side of your big X, it's going to be the square root of that number. So the square root of 36, right, which would be 6. And difference because one's a positive, one's a negative. All right, so we got our greatest common factor of 3. And let's write our factors in here. So we've got t plus 6 and t minus 6. And again, if you caught your mistake, pause it. See if you can finish the rest of the problem from here. So don't just copy down what I'm writing. Try to do as much of this as possible as you can on your own. All right, so let's divide by A. So dividing by A, again, our A in this case, there's our A right there. Our A is 9. Well, it doesn't divide evenly, right? Can't divide evenly, so I'm going to have to reduce. So before I slide it, I'm going to have to reduce it. And let me divide by 3, because that's what will go into both one of them, or each one of them. And then so when I reduce those fractions, end up with t plus 2 over 3 and t minus 2 over 3. Now, I can't divide it. I've reduced it. So now, if you can't divide it, slide it. So let's go ahead and slide that over. I'm going to slide over the 3, slide over the 3. And so we get 3 times 3t plus 2, 3t minus 2. All right. So try, pause now. Try number 9-3 on the right side. Okay, so let's see what you got for 9-3. Should have got 5 times 2t plus 3 times 2t minus 3. All right, well, hey, we're almost there. Number 10, you survived. Thanks for hanging in there. All right, so in this last one, actually, it's good. We'll finish on a positive note here with something that hopefully should be pretty easy for you. Checking for a GCF. Nope, don't see a GCF. All right, looks good. Trying to figure out what my A, B, and my C are. This is also another difference of squares, right? So this is also another case of where the B is missing, and the B is missing because it's equal to 0. So as far as my A and C, again, I'm going to cross out the B, right? Because it's equal to 0, right? So as far as my A and my C, so here's my A, which in that case is 1, and then there's my c, which is negative 16. So I'm going to go ahead and fill in my big X here. I've got two numbers that multiply to negative 16 that add up to 0. Well, now don't say 8 and 2, because that doesn't add up to 0, right? Positive 4 and negative 4. Again, with this difference of squares, it's going to be the square root of that number. Right? All right, so let's take that over. And so I've got p plus 4 times p minus 4. And let me divide by a. And again, you know, what we notice here is that a is equal to 1. So we know when a is equal to 1, it's just going to end up being the same thing. P plus 4 times p minus 4. And again, don't do squared because they're not the same, right? It's only when they're identical that we can do that. And again, because a was equal to 1, there was no, you know, if you can't divide it, slide it. Well, we could divide it. We divided by 1, so there was nothing to slide. All right, so try number 10-2 in the middle. All right, should have that finished by now. So 10-2 in the middle should have got p plus 6 times p minus 6. And let's just see real quickly where that came from. If you got that, go ahead and try 10-3 on the right side. If not, just hang on here and we'll kind of go through it. But again, you really, hopefully by this point, right, because we're at the end now, so hopefully you're feeling pretty strong about this. Hopefully you're feeling better about this than when you started the video. Right, so here's our A, there's our C, as we said, no B. And we're looking for two numbers that multiply to negative 36 that add up to 0, which would be positive 6 and negative 6. So I've got p plus 6, p minus 6. You know, you might wonder, you know, do I have to do this whole divide by a thing? You know, once you get enough practice with this, I would say that's a step you can take. But if you're here, because you didn't pass the test the first time, you maybe want to get in the habit of doing that first, right? So maybe eventually you can take the training wheels off, but maybe keep them on just for a little bit longer. So p plus 6 and p minus 6. All right, so go ahead and pause now and try 10-3 on the right side. All right, so 10-3 on the right side should have come up with p plus 8 and p minus 8. All right. Well, we're at the end. So now that you've completed the study guide, it's now time for you to redo the test. Hopefully you feel better about the material now that we've had a chance to go over you with it. Over it with you. Wow, I can't even talk at this point. So thanks for listening to me and some of my bumbling mistakes there. Like I said, it's 9:38 on a Sunday night for me, so I'm a little tired. I'm sure you're a little tired at the end of a long school day, but hey, you're here, you made it, you committed to doing something about your grade, and that's what the most important thing is. So thanks again. Go ahead and stop the video now, and good luck on your test. All right, we'll see you next time.